Lesson 6.6, Inequalities. An equation is an equality. It's a statement that two values are equal to one another. Equation means equal, and it will contain an equal sign. An inequality is a statement that two values are unequal, and it will provide an indicator as to which value is higher or greater. It will contain one of the following: this symbol, which is read as is less than or is fewer than; this symbol, which is greater than or is more than; we have is less than or equal to or at most; and we have is greater than or equal to or at least. Solving an inequality is using the same steps as solving an equation, and there's only one major difference. The first step will be to distribute, if necessary. Distribution is not always in the equation or inequality, but we do it if it's there. Then we collect like terms on each side. We'll do adding or subtracting in an attempt to isolate the variable. And finally, we'll multiply or divide. If we divide by a negative, we have to flip the inequality system. This is the major difference that I just mentioned. So first we'll start with single-step inequalities. Here's a few single-step inequalities. So to start this process, we'll look at the first example, which is 3x is greater than 18. Our first step will be to divide by 3 on both sides, just as we would if this was an equation, because the 3's will cancel. And we will receive or get x is greater than 6. Our next inequality is x divided by 5 is greater than or equal to negative 13. So first I'm going to rewrite that so I can have room to show the next step. It's 13. To undo division, we'll multiply both sides by 5 because these 5's will cancel, which will leave us with x is greater than or equal to negative 65. Next, we have x minus 6 is less than or equal to 21. Our first step will be to add 6 to both sides, which will give us x is less than or equal to 27. Finally, we have negative 6x is greater than 36. Here we're going to be dividing both sides by negative 6, which means we're dividing by a negative, and that means we need to flip the inequality. I just draw that to kind of remind you that we have to flip the inequality. So anytime you multiply or divide by a negative, flip the symbol. That gives us x is less than negative 6. The reason we need to do this is because multiplying or dividing by a negative changes the truth value of the inequality. For example, if I have 2 is less than 5, but I multiply both sides by negative 1, I get negative 2 and negative 5. Negative 2 is not less than negative 5. Negative 2 is greater than negative 5. So that's why we have to make this flip. So next we'll solve some two-step inequalities. Here are 4 more examples. In our first example, negative 3x minus 5 is less than 10. So the first thing we'll need to do is to add 5 to both sides. This will give us negative 3x is less than 15. We then divide both sides by negative 3. And we divide it by negative, so we need to flip that inequality. That will give us x is greater than negative 5. Our next example, x divided by 3 minus 3 is less than or equal to negative 6. Our first step will be to add 3 to both sides, which gives us x divided by 3 is less than or equal to negative 3. To clear our division, we'll multiply both sides by 3. These will cancel, which will give us that x is less than or equal to negative 9. Now, you'll notice that I was multiplying and there was a negative involved, but I didn't multiply by a negative, therefore I did not have to flip the inequality. Next example, negative x plus 2 is greater than 7. First, I subtract 2 from both sides. Next, I have negative x is greater than 5. Now, I don't want to know what negative x is. I want to know what x is. So, in order to clear this negative, I can multiply both sides by negative 1 or divide both sides by negative 1. And if I do that, I need to flip my inequality symbol. That will give me x is less than negative 5. Now, you don't necessarily have to incorporate this multiplying by negative 1 step. If you have a negative variable, you can change both signs and flip the inequality. And just remember to flip the inequality and you can solve it that way. Our last example on a two-step inequality, I have 4 plus x divided by 6 is greater than or equal to negative 5. My first step is going to be to subtract this 4. That will give me x divided by 6 is greater than or equal to negative 9. And then I'll multiply both sides by 6. And I will get that x is greater than or equal to negative 54. So those were the two-step inequalities. Next we have multi-step inequalities. And I have two examples, one with variables on one side and one with variables on both sides. Now we had mentioned before that the first step will be distribution if necessary, and this problem has distribution in it, so we'll need to do that. Now here I have negative 3 minus 6 times 4x plus 6 is greater than negative 11. So I need to distribute this. And it's very important that you remember to bring the negative with the 6 when you multiply it in, so that you're changing signs as necessary. This negative is like this 6's car keys. It can't go anywhere without them. Once I do that, I have negative 3. Negative 6 times positive 4 will give me negative 24x. Negative 6 times positive 6 will give me negative 36. It's greater than negative 11. The next thing I need to do is combine like terms. I have negative 3 and negative 36. Those are like terms. So I'll add those together to get negative 39 is greater than negative 11. Add 39 to both sides. And I get negative 24x is greater than 28. Divide both sides by negative 24. And you get that x is less than, we divided by negative, so we had to flip. Now 28 does not divide evenly by 24, but this is a reducible fraction. If I have 28 over 24, they'll both divide by 2 to give me 14 over 12, which will both divide by 2 to give me 7 over 6. Now I have this negative in the denominator, but we don't leave negatives into the denominator. We'll bring them out front. So this will be x is less than negative 7/6. For our last example, I do have some more distribution. I need to remember when I multiply in to bring that negative with me. So it's negative 3 times 5 and negative 3 times 7a. On the left-hand side here, I have nothing to do, so I'm going to just rewrite that. Negative 3 times 5 is negative 15. Negative 3 times 7a is negative 21a. I'll add 21a to both sides to get all of my variables together. This will give me 30 plus 15a is less than negative 15. Subtract 30 from both sides to isolate the variable. And we get 15a is less than negative 45. Next, I divide by 15 to get that a is less than negative 3. Okay, now we need to graph inequalities. And the graph of inequality with one variable is graphed on a number line. So we should probably make a note of that with one variable. We will be graphing inequalities in two variables later on in the algebra course. Here's our number line. The graphs use circle and shading to indicate all of the values that make the inequality true. Because we have an inequality, for example, x is less than 3, there's more than one number that is true. 2.9 is less than 3, negative 76 less than 3, 0 less than 3. So we have to have a way to indicate that there are a lot of numbers that make this true. We use an open circle on our graph if we have a less than or a greater than, and an open circle is a circle that is not filled in. We use a closed circle on a graph with less than and or equal to and greater than or equal to, and a closed circle is a circle that is filled in or colored in. Okay, so how we graph the inequality is the first step is we need to solve it. So I'm going to go through and solve this quickly. We add 5 to both sides. We get negative 3x is less than 15, and then we divide by negative 3, and so we have to flip our inequality symbol, and we get x is greater than negative 5. So here's our solution. This is the first step. Then we create a number line. Now, depending on who you work with, some people are very particular about the way number lines are filled out. Some people are not. I tend to go on the less particular side. So my number lines, typically I put a 0 somewhere in there, and then I put my solution number on the correct side. And they're very sort of empty. Other people really want those numbers, filled out. So you have 1, 2, 4, 6, negative 2, negative 4, negative 6, etc. It just depends. But so we need to create the number line. Then you want to put an open or a closed circle on the solution number. Here our solution number is negative 5, and we need an open circle. So we put an open circle on negative 5. I'm going to just do this on both graphs. Then you shade the number line on the correct side of the circle. And by the correct side of the circle, it's the side with the true values. Some of you may have done this in the past and been told to shade which side the arrow points. This only works if the variable is on the left. If you learn to shade the true values, it won't matter where the variable is located, and it won't matter which way the arrow is pointing. You'll just know which side is accurate. So we're looking at this. We have x is greater than negative 5. Okay, that tells me all the numbers that are bigger than negative 5 are going to make this true. Over here we have negative 6, negative 7. Those are smaller than negative 5. And over here I have 0, 2, 7, greater than. So I'm going to shade the side where the numbers are true. Keeping in mind that if you have an open circle, you want to keep that open. Don't color it in. So here are a few examples. We're going to solve and then graph these. So for our first, I have some like terms here that I need to combine. So I have -2 is greater than or equal to 4p plus 10. I'll subtract 10 from both sides, and I get -12 is greater than or equal to 4p. Then I'll divide by 4, and I get -3 is greater than or equal to p. And this is one of those times where it makes sense to learn not to rely on which way the arrow is pointing. Here's why. I have 0, and I have -3, and I have a closed circle because I have a less than or equal to, and p, -3 is greater than p. That means p is going to be over here on this side with all the numbers that are smaller than p, or sorry, smaller than -3. And you see I did not shade the way the arrow was pointing, and that's because my variable was not on the left. So just keep that in mind. Here I have 33 plus 4x is less than or equal to -x plus 7. This negative outside needs to be distributed in. So 33 plus 4x is less than or equal to -x minus 7. Then I can add x to both sides, remembering that, of course, if there's no coefficient, that's the same thing as a 1. So I get 5x is less than or equal to -7. Subtract 33 from both sides, and I get 5x is less than or equal to -40. Divide by 5, and I get x is less than or equal to -8. I have 0, I have -8, closed circle because of less than or equal to, and the numbers that are less than or equal to -8 are on this side, so we'll shade over here. Next example is 2 times 6 plus 4n is greater than 12 minus 8n, and then we have -3 times -7p minus 6 is less than p minus 29. What I would like you to do now is pause the video for a moment, try to work these problems out, and then graph them and see how you do. We'll go over them after you unpause the video. Okay, so let's check your work. I've written out all of the steps. You should have gotten n was greater than 0, open circle and shaded to the right. And then you could have gotten p is less than -47/20, open circle and shaded to the left. Lesson 6.7, Graphing Inequalities. In this lesson, we're going to be discussing compound inequalities. And a compound inequality is like a compound sentence. It's an inequality that's joined with an and or an or. The first type of compound inequality that we have is called a conjunction. A conjunction is a math sentence combined with the words and. They're also known as intersections. And just like if you have two roads and they have an intersection, that's the place where they meet. It's also the part of the both roads that they have in common. A conjunction is the part of the inequalities that overlap. So you have two inequalities joined with the word and we're looking for the part that overlaps, the numbers that the two inequalities have in common. The second type of compound inequality is called a disjunction. A disjunction is a math sentence that is combined with the word or. It's also known as a union. And just like if you think of a union in non-math life, a union is a marriage, or a union as in the union of the states in the United States. It's the total of both inequalities. So everything that they have in common as well as everything that they don't have in common, all combined together. So we'll start with conjunctions, and conjunctions may or may not have the word and in them. Here are two examples of conjunctions. You'll see that the first example has the word and the second example does not. They're both conjunctions. So we're looking for the intersection or the overlap. And in order to solve these, we solve them the same way we would solve equations. There's a little difference over here, but in our first example, we have two inequalities and we'll solve them separately. So in our first one, we'll add 5 to both sides. This will give us 3x is less than 15. Then we'll divide both sides by 3. And this will give us x is less than 5. This one is completely solved. Now we'll come to the second one. To start, we subtract 11 from both sides. That will give us 2x is greater than negative 14. We'll divide both sides by 2. And that will give us x is greater than negative 7. Now to keep this as a conjunction, when we write our answer, we write that with the word and in the middle. So here's our solution to this set of inequalities. If it's written without the word and, what you have is essentially two inequalities put together that the expression portion or the variable portion are the same. This is 6 is less than 3x plus 4 and 3x plus 4 is less than or equal to 31. And when we solve these, if we come back and we look at our first example, we have two sides to the inequality, 1 and 2. So anything we did to this side, we also do to that side. In this combined format, we don't have two sides, we have three sides, 1, 2, and 3. So anything we do to the one, we have to do to the other two as well. So whereas before you subtracted 11 twice, here we're subtracting 4 3 times. So anything you do to one part, you have to do to all three. So let's work on solving this. Okay, our first step is going to be to subtract 4. And again, we don't have two sides, we have 3, so we subtract 4 in 3 places. That gives us 2 is less than 3x is less than or equal to 27. After we've done the subtraction, we're going to divide all three sides by 3. 2 doesn't divide by 3, so we get the fraction 2/3 is less than x is less than or equal to 9. And in this format, we don't have to use the word and. We just present it exactly the way it turns out. Well, when we work with inequalities, we often have to graph them. So we need to learn how to graph the conjunctions. So if you recall, in our first example, we had two solutions. X is less than 5 and x was greater than negative 7. If we were to look at each of these individually, x is less than 5, x is greater than negative 7. To graph x is less than 5, I put the open circle on the 5 because we're less than. And then I graph, or shade rather, all of the numbers that are less than 5. Everything on this side of the number line is true. Now if I want to graph the solution x is greater than -7, I put an open circle on -7, again because I only have a greater than, not an or equal to. And then I shade every number that'll make that true. So all of the numbers that are greater than -7. When we look at this, x is less than 5. That means none of these values are true. Here we have x is greater than -7. That means none of these values are true. When we put these together, these untrue values will still be untrue. So our x between the two inequalities is the same x. So if x has to be less than 5, 10 won't work. Or if x has to be greater than -7, -9 won't work. So in order to graph the actual conjunction, we need to look at the combination of the two graphs. And we shade the area in between. This is the part that is true for both inequalities. So this is the solution. This is the graph for x is less than 5 and x is greater than -7. So how do we graph this without having to graph all three graphs to figure out which area to shade? Well, let's get our solutions back. Okay. What I recommend is we look at each individually. I said x is less than 5. I'm going to make my open circle on 5, and then I indicate for less than that I would need to shade in this direction. So this would all be shaded. And then I have x is greater than -7, so I put my open circle on -7. And everything greater than -7 is this way. And when my arrows point towards each other, like they are here, I know that I need to shade the area in between. So once I have this set up, I come in and I shade what's in between. Then I don't have to make all three of those graphs that we just looked at. I can do it all on one graph. Now to graph our second example, we had 6 is less than 3x plus 4, which is less than or equal to 31, which gave us 2/3 was less than x was less than or equal to 9. Now to graph, I'm going to apply a similar technique. I need to find 2/3, which 2/3 is about right here. And I'm going to put an open circle on 2/3, and then I have 9. I'll put an open circle on 9. Now x is in between 2/3 and 9, and that tells me that I need to shade in between 2/3 and 9. I don't have to do a lot of work with this. That part right there indicates to me where to shade. So I'll come in and I will shade between 2/3 and 9, just as x was lying. Okay, here are some more examples. What I would like you to do is pause the video, try graphing them, and then when you're done, unpause the video and we'll go over them and you can look at your work. So let's check and see how you did. You should have gotten 0 was less than x was less than or equal to 5. And n is greater than or equal to -3, and n is less than or equal to 3. On the graphing, you should have an open circle on 0, a closed circle on 5, and have shaded in between, and closed circles on 3 and -3, and have shaded in between. The next thing we need to discuss are disjunctions. And again, remember, disjunctions are used with the word or. There are no combination disjunctions, so you will absolutely see the word or if this is a disjunction. Whereas and you had two options, with or you only have the one option. So it'll look similar to this. You'll solve each inequality separately. So for our first step, we'll add 10 to both sides to give us 8x is greater than 48. Then we will divide both sides by 8 to give us x is greater than 6. Then we'll come to our second inequality. We will subtract 5 from both sides, giving us negative 3x is greater than or equal to negative 3. We will divide both sides by negative 3, and don't forget we're dividing by negative, which means we need to flip that inequality symbol, which will give us x is less than or equal to 1. Writing this out, you'll have x is greater than 6 or x is less than or equal to 1. Don't forget to put the word or between the two. In order to graph a disjunction, we'll do a similar technique as we did before. Okay, we had x was greater than 6 or x was less than or equal to 1. So let's graph x is greater than 6 and x is less than or equal to 1 separately first, and then we'll graph our disjunction together. Starting with x is greater than 6, I need to put an open circle on the greater than, on the 6, and then I shade the side of the graph that is greater than 6. Okay, to graph x is less than or equal to 1, I put a closed circle, and I graph the part that is less than or equal to 1. Now you'll notice that these graphs do not have an overlap like we had before. Now you'll remember also we had said that the word or indicated a union, which indicates combining, not overlapping. So to graph this disjunction, or the or one, putting these on both the same graph, I would draw my arrow to shade that way, and I would draw my arrow to shade this way. And when my arrows point in opposite directions, I shade in opposite direction. So I will shade this direction and this direction. Very occasionally, you will get a disjunction that the arrows point to each other. When that happens, you shade the entire number line. You have all numbers. So here are two more examples. Again, I would like you to pause the video, work these out, graph them, and then come back on and compare. So now we're back, and I've solved the equations, the inequalities, and I have them graphed. So let's compare your answers and see how you did. For example 1, you should have gotten n was greater than 8 or n was less than 4. On the graph, you should have open circles on 4 and 8 with shading going in the opposite direction. For the second example, you should have gotten x was less than or equal to 7 or x was greater than 9. You should have a closed circle on 7, an open circle on 9, and the shading going in opposite directions.